Today we will see the midpoint method and how we can find the desired root of a number with this method. Let's first find out what the midpoint method is. Midpoint method. Let's take the points a, b and x0, x on a line. Here, x0 is the root we are looking for, and x is the midpoint of a and b points. If x equals x0, we're done, we can finish. What do we do if x is less than or greater than x0 ? Let's first examine the case where x, that is, the midpoint, is greater than x0, that is, the root we want to find. If x is greater than x0, we no longer need point b. We can equate b to x. Because x0 will stay between point a and point x. To get closer to the root, we compress it to stay within a certain range. So if we're already looking for the value x0, how do we know that x is greater than x0? Namely, we assume that the x value is the root sought and we take the exponent of the root value. If the root of the result is greater than the number searched for, then x is greater than x0. And the reverse is also true. When we do this, we must also find the new x, the midpoint of the new state. This is how we do it. The second situation is that the middle note is smaller than the root. Here, too, we do the same. This time we set point a to the value x. And we find the new x value in the same way. So now we can write the algorithm for the midpoint method. Now let's write the algorithm of the midpoint method, its equivalent expression in the very famous Python language. You can try this code online at sites running Python, or you can run it with the Python interpreter if you have it installed on your computer. The code contains standard commands and does not use an extra library. Now let's do a few tries. Let's take the number 4096 and calculate its third root, that is, the cube root. The cube root of 4096 is 16. Let's take the number 500 and find its fourth root. We found such a number. When we calculate this with the computer's calculator, we see a very approximate result. Let's briefly analyze our work. We got a number. In an interval where the root of this number can be found, we have found the midpoint of that interval. Let's put a light rectangle if this point is larger than the searched root, and a dark rectangle if it is small. Yes. Here are the results for the fifth root of 800 and the sixth root of 10,000. As you can see, there are more open quadrangles. So there is a tendency to approach the root from the top. Because roots become more precise than a number divided by 2. Subscribe to our channel, like videos, turn on notifications and share. Thus, Let us deliver our topics, which will increase in number and quality, to you and everyone.